So this is part two of the work, energy, and power lesson. So we stopped off at falling under gravity. Now this picture is showing a man on top of a springboard. So the diver in the diagram uses 6,000 joules of his chemical energy to reach the springboard. Here at the top, here at the top, he gains 6,000 joules of gravitational potential energy. But he has no kinetic energy. What this basically means is when he's on top over here, gravity is pulling him down at 600 joules. But he has no kinetic energy because he is not moving. And because remember, kinetic energy is movement energy. Now, when he jumps off, his potential energy is changed to an equal amount of kinetic energy. So it changes to kinetic energy when he jumps because he's moving. When he hits the water, all his potential energy has been changed to kinetic energy. When he hits the water, there is no potential energy, but there is kinetic energy. 6,000 joules. So you can see that a gain in kinetic energy is a loss in potential energy, because when you jumped off, you gained kinetic energy and you lost potential energy because you're no longer standing in the same place. Then when you're falling, you lose kinetic energy and you gain potential energy. Wait, that doesn't make any sense. Let me go back. Basically happening here is that kinetic energy is changing, potential energy is changing to kinetic energy. That's basically it. Now, potential energy is the scientific name for stored energy, and it can be divided into three types. So, potential energy can be elastic potential energy, gravitational potential energy, and chemical potential energy. Now, energy can be stored in many ways. It can be a gallon of petrol, for example, with stored energy, which is chemical energy. Um, for example, when Robin Hood stretches his bow, it also has stored elastic energy, sorry, because when you're pulling the bow, uh, you're creating elastic potential energy, stored energy. When you let go of the bow, that elastic potential energy changes to what is movement energy, kinetic energy. Looking at this picture, you can see a pot with a plant. Now, in the first picture, it's falling from the first floor. And when it falls from the first floor, it doesn't break, apparently, because it's made. I don't know how it doesn't break, but actually, there is damage, but it's very, very little. Now, if you drop the plant from the third floor and it falls, the pot will smash. Why? Now, over here it says that the higher up an object is, the greater the gravitational potential energy. So the larger the height, the larger the amount of gravitational potential energy. So added to that, since gravitational potential energy gets changed into kinetic energy, so when the plant falls, it's changing from potential energy when it's at rest, and when it falls, it changes to kinetic energy. So the higher up the object starts from, the faster it will be falling when it hits the ground. So the higher you let go of something, the faster it hits the ground. So a change in gravitational potential energy depends on the height an object moves through. Added, Adding to that, um, this is another example. Lifting an apple, which is this lady is holding, lifting an apple 1 meter is easier work than lifting an apple tree the same height. This is because the mass of the tree is, of course, it is larger than the mass of one apple. So it needs to be given more gravitational potential energy to reach the same height. So a change in gravitational potential energy depends on the mass of the object that is changing height. So mass is very important. Now, calculating gravitational potential energy. The equation is gravitational potential energy equals mass times gravity times height. Mass is in kilograms. Gravity is always the same on Earth, so it's 10. And h is the height. In meters, not centimeters, it's important. So let's work out an example together. Calculate the potential energy when a car of mass 500 kilograms climbs a hill of 400 meters high. So you know that the mass is 500. 500. You know that gravity is 10 because it's always 10. And you know that the height is 400. Now, we know, so 500 times 10 times 400, which is equal to 2 million. So the gravitational potential energy in this case is 2 million joules. Now, B. A climber of mass 65 kilograms stands on a table 95 centimeters high. So let's remove this. So we know the mass is 65 because it tells you 65 kilograms. We know that the gravity is 10. And now the height is 95 centimeters. Now remember when we said it all has to be always in meters, so you have to change 95 into meters. So to change 95 into meters, you have to divide it by 100. And if you divide 95 by 100 is equal to 0.95. So you know that the height is 0.95 meters. So let's times all these together. So I times everything together and the answer is 617.5. And those were just a few examples. Now, let's just do one more. So a rifle shoots upwards a bullet of mass. We are on page 40, no, not 40, page 11. A rifle shoots upwards a bullet of mass 0.02 kilograms. The chemical energy stored in the gunpowder is 150 joules. So A. If 30% of this chemical energy is converted to potential energy, calculate how much potential energy the bullet gains when it is fired. So the first thing we have to do is we have to find 30% of this 150 because this is saying if 30% of this chemical energy, if 30% of this 150 joules is converted to potential energy, how much potential energy does the bullet gain when it is fired? So to find 30% of 150, all you have to do is use this method. So we know that 100% is equal to 150 joules. That's the total amount of chemical energy there is. Now we have to find 30% of that 150. So what you do is you times this with this and you divide it by 100. So let's check. So you times 30 by 150, which is equal to 4,500. Then you divide it by 100. And the answer is 45. So we know that 30% of 150 is 45 joules. This one's a bit tricky. He's asking you to calculate the maximum height that the bullet can reach. So, no, not this one. So we know that the gravitational potential energy is equal to mass times gravity times height. Now, let me just erase this. In the previous example, we found that the potential energy is 45. Sorry. We know that the mass is 0.02 0.02. We know that the gravity is 10. And we need to find the height. So, you remember how to do these. This is calculating the subject of the formula, basically. So, what you have to do is you have to times these two together. And I know that that comes 45 is equal to, you move the point forward if it's timesing. So the point goes to after the 0. So that comes 0.2 times, no, 0.2 times the height. Now, you want the height on its own, so you have to take the 0.2 to the other side. Now, if it's timesing with the h, what does it come on the other side? Think a bit. It comes division. So 45 division by 0.2 is equal to 225. So the maximum height the bullet can reach is 225 meters. Now, if only 30% of the chemical energy is converted to potential energy, what are the other two types of energy that are formed after the bullet is fired? So, what are the two types of energy? So you have potential energy. Now, if the bullet is moving, what kind of energy is that? Remember the name, it starts with K? It's kinetic energy. And what else? Do you think the bullet is hot? Yes, it is. So the two other types of energy are kinetic energy and heat energy. Moving on to kinetic energy, and we'll end the video here. Kinetic energy tells us how much moving energy something has, so how much moving energy. For example, a Formula 1 car has more kinetic energy than a Kia, which is like a normal car. This is because the F1 car has a greater velocity. This means that the kinetic energy depends on the velocity of an object. Now, a running elephant has more kinetic energy than a running man because it has more mass. So this means that kinetic energy also depends on the mass of an object, so it depends on mass and velocity. Now, to calculate kinetic energy, the formula is half times mass times velocity squared. Now, over here it says, so kinetic energy is in joules, mass is in kilograms, and velocity is in meters per second. So kinetic energy exists whenever an object which has a mass is in motion with velocity. So whenever something with a mass is moving, that's kinetic energy. It has kinetic energy. Everything you see moving about it has kinetic energy. An object at rest has no kinetic energy.